Let's discuss about scientific notation, why we need it, how to write a given number in scientific notation, etc. So this is an example of a number written in scientific notation. The things we need to notice is there's only one significant integer before the decimal, and whatever comes follows after the decimal. And we could have a sum power of 10 to make sure we get the right number. So in fact this number is 71,420,000. On the left side we write it as 7.142 times 10 to 7 in scientific notation. So a number written in scientific notation, we can only have one digit before the decimal. However many digits can follow the decimal, and then it's followed by the appropriate power of 10. So let's look at this example. We have 312,600,000. So we have 1, 2, 3, 4 significant digits. 3, 1, 2, 6. The first one is 3. So the form this is going to look in scientific notation is this. First significant digit 3 followed by the decimal, then the rest of the digits follow 1, 2, 6. All we need to decide is what power of 10 we need to put here. So if you compare what we have here with the original number, 3.126 has to be multiplied by powers of 10 a certain number of times to get to 312 million plus. So if you look at how many times we have to move the decimal in 3.126, it's going to be 6 plus 2, 8 places to the right. So 3.126 has to be multiplied by 8 powers of 10. Therefore, the answer in this example is going to be 3.126 times 10 to the 8. Let's look at another example. We have a decimal followed by a bunch of zeros, then the significant digit 736. So the form this should look in the scientific notation is 7.36 times 10 to the appropriate power. So 7.36 times 10 to some power. So if you notice the original number, we need to keep dividing now the 7.36 to get to that smaller number, 0.00000736. So it looks like we have to divide 7.36 by 7 powers of 10. So the number will look like this, 7.36 times 10 to minus 7. Here is another example, slightly different. At a glance it looks like it's already written in scientific notation, but if you carefully look at it, it's not. So have a look at it and see if you can figure out if it is why it's not in scientific notation. It's not in scientific notation because there are 2 significant digits before the decimal. You cannot have 2 significant digits before the decimal in scientific notation. There can only be 1. So this should be written as 3.4146 times 10 to the appropriate power. So to write this in scientific notation, I'm going to initially ignore 10 to the 12, but of course keep it along. Just write 34.146 in scientific notation first. So that's going to be 3.4146 times 10 to the power 1. Now we can combine the 2 powers of 10. When you multiply those two, we simply add the exponents. So we get 3.4146 times 10 to 13. The reason why we use scientific notation in sciences is we can write very large numbers and also very small numbers without writing all these zeros. We can compensate for those writing like very large number of zeros by writing it as some appropriate power of 10. So it's a very efficient way of writing large and small numbers which we commonly encounter in sciences. Here is an example which includes everything we can expect in an example in the exam or the quizzes. First, we need to write each of these numbers in scientific notation. Remember, there are 3 parts to this. Writing everything in scientific notation, evaluating or simplifying the result, and take the result and write that in scientific notation. So let's take care of the first part. Decimal bunch of zeros 645 should be written as 6.45 times the appropriate power of 10, in this case minus 7. 76,400,000,000 can be written as 7.64 times 10 to the power positive 10, and 142 million can be written as 1.42 times 10 to the 8. Now all these three numbers are in scientific notation. Next, to simplify, I'm going to separate some of these numbers. You can wave this as 6 different numbers. So I'm going to separate 6.45 times 7.64 divided by 1.42 times the powers of 10. 6.42 times 7.64 over 1.42, I can use the calculator for that, gives me 34.7. The powers of 10 multiplying, I need to add the exponent. So minus 7 plus 10 gives me plus 3 in the numerator, 10 to the 3. I still need to divide by 10 to the 8. So 10 to the 3 divided by 10 to the 8, I need to subtract 8 from 3, which gives me negative 5. So the result is 34.7 times 10 to the minus 5. If you observe, again this number is not in scientific notation because there are two significant digits before the decimal. I cannot have it as 34.7. I need to have it as 3.47. So we're going to do the same thing as what we did in the previous example, right? 34.7 in scientific notation, then join the powers of 10. So 34.7 in scientific notation is 3.47 times 10 to the 1 multiplied by the power we already have. So now we can combine the two powers of 10 to give us 3.47 times 10 to the minus 4.